All right, let's get started today. So we've got a couple of bell work problems. I don't want to spend a lot of time on them, but we got this diagram here, and they want us to know, do we know any alternate exterior angles? And just quickly, I just look at that and say, oh, I got 2 and 7 or 1 and 8. So I would put 2 and 7 or 1 and 8. How about corresponding angles, angles that are in the same position? Well, 4 and 8 are, and there's several others. So I just pop in 4 and 8 are in the same position in this diagram. Alternate interior angles. Well, let's take a look at that. Well, here's the interior. Here's 4. We've already used 4 once, but an alternate interior angle with 4 would be angle 5. 4 and 5. So these should be getting pretty easy, pretty automatic for you. If not, we need to, get with one of us teachers and figure out what's going on here. Okay, on this one, we just need to find x, we just need to subtract, well, we've got 84 and 48. We need to subtract those from 180. So we're going to do 180, subtract 84, and subtract 48. So those two numbers right there, 48 and 84, add up to 128. So that takes off the 100 here. So we've basically got 80 minus 28, which gives us 80 minus 28 would be 80 minus 28. Tried to do it in my head and it was just not happening. Okay, 10 minus 8 is 2. 7 minus 2 is 5. So that would be a 52-degree angle. This is one of the exterior angle theorems where this angle out here is the sum of these two angles on the inside. So that would equal 142 degrees. So pretty easy problems. Should be getting pretty automatic for you. Okay. Yesterday we talked about similar triangles and congruent triangles and other figures, and we just mentioned that something like this where you get a couple of angles and you have to find some missing ones over here, and we know that the smallest one over here corresponds to the smallest one over here, so angle H would be 20. The biggest one over here corresponds to the biggest one over here, which would be 110. And then if you add those two together, that's 130, and 180 minus 130 would be 50 degrees. So this would be a 50-degree angle, as would Y, 50 degrees. So pretty slick, wasn't it? Okay, how about this one? We talked about how to find a missing angle. Let's call it X. So we set up a proportion. We've got X that corresponds to, on the left, corresponds to the number 8 on the right. And then we're going to set up a ratio between these two and another couple of numbers. So we'll go with 45 and on the left and 5 on the right because it corresponds to it. And so if we solve this proportion, 45 times 8 divided by 2, we end up with X equals 72. I happen to do that one in my head without getting out my calculator, but that would be 72 degrees. Okay, let's keep moving. All right, what if we don't have a triangle? We have a multi-shaped or multi-sided shape. 1, 2, 3, 4. We got a 5-sided shape here. So we're looking for X. X happens to be on the right side this time, so we'll put it on the right side in our proportion. X equals, and X corresponds to the number 6, so we'll put it over on the other side. And now we're going to make a ratio out of two other numbers that go with X and 6. And we've got 4 others to choose from. So let's look at, see, we got some, these are decimals this time, that's okay. So let's go with the 3.2 on the right side. Then we have 2 on the left side. And so we're going to multiply 6 times 3.4, or 3.2, which would be 19.2. So we have 19.2. And then we're going to divide it by 2 to get X. And 19 divided by 2. Let's see, 19 divided by 2. I know that 9 times 2 is 18. There's 1 left over. So it's going to be 19. So it's going to be 9.5 is the number we're looking for. Okay, so be a couple more of those on today's assignment. Here's another one, a similar triangles, and we're looking for x. We notice that x corresponds to the number 8. So let's write that down. X equals 8 on the other triangle. And now let's set up a proportion between the other two sides that they do give us. 2.5 and 4. Well, I happen to notice if I divide 8 by 4, I get 2. So what number would I have to have here in order to divide it by 2.5 and get 2 as well? Or if I cross multiply and divide, I end up with x equals 5. So that would be my answer on that one. Okay, now here's another one, and sometimes we extend these a little bit differently. So we got a 9 on the diagonal, 4.5 here. And if we extend it out a little bit, this side gets a little longer, this side gets a little longer. We could illustrate it like this. This side just got 3 longer, so how long would this side be? So the way that we do that is we take these two sides and add them together, and this whole side equals 12, right? Okay, so we're looking for x, so we write down x, and x corresponds to the bigger side over here, which is going to be 9 plus 3, x. 12 over 9, excuse me, because we're doing the big side over the small side, the big side over the small side. So 12 over 9. So we would multiply, cross multiply, and then divide. And so 4.5 times 12 divided by 9, it's going to give us, well, let's multiply it out. 4.5, so I'm going to have 12 times 4.5 over 9. And then the 4.5 over 9 will simplify, and it'll leave us with just 2 on the bottom. And 12 divided by 2 is 6. So x would equal 6 in this case. So sorry, that was a little bit of a struggle for me. Okay, let's move on to another one that's not written quite so difficult, I guess. So suppose a flag casts a shadow that is 21 feet long. A student that is 5 feet tall is standing next to the flagpole and casts a shadow that is 6 feet long. What is the height of the flagpole? Okay, so we're going to call the flagpole x. And x corresponds to 5. So x, and our ratio on the left side, 5 for the man, and then the shadow of the flagpole and the shadow of the man. So to solve this, we would do 21 times 5, which would be 105. Yeah, 5 times 20 is 100. So this is going to, x is going to be 105 divided by 6. So what would that be? Let's grab our calculator. 105 divided by 6, 17.5. So the height of the flagpole is 17.5. That's not a very good one, but 17.5. What do you think of that? Okay, this is called indirect measurement, where we can measure the height of the flagpole using a measurement that we can get to. Now here's an interesting problem. Let's say we've got a river here. We want to know how wide it is. Okay, so we step out a triangle on this side, then so a little length of 31 meters and a length here of 21.7 meters. Okay, then we come down to the riverbank and we step along a distance of 65 meters, and then we're trying to find this length right here. So this length corresponds to 21.7. So x corresponds to 21.7. And then the number that goes with x is 65. So x over, so we're setting them side by side. So this is going to be 65 over 31. So So let's multiply that out, get our calculator handy. We've got 65 times 21.7 equals, divide by 31, and that equals 45.9. So x equals 45.9. Now, something that I've seen a few students doing when they do a calculation like this, let me hit clear, and I want to show you. Some of you have been maybe multiplying or adding in a different order, and the calculator messes up the order of operations. You have to make sure that you give it the right numbers. And it's usually related to when you're adding two numbers and then dividing by a third number. So be careful with that. Okay? All right, a pole that is 2.6 meters tall. So here's our pole, and it's 2.6 meters tall. Cast a shadow here that is 1.64 meters long. Okay, at the same time, a nearby building, a big old tall building, casts a shadow that is 50.75 meters long. So we can set up a proportion here and find out how tall this building is just based off of these measurements. So we've measured these, and now indirectly we can find this. That's why we call this indirect measurement. So x on the left side corresponds to 2, or on the right side corresponds to 2.6 on the left, and then 50.75 corresponds to 1.64. So let's get our calculator back out. And we're going to do 1.64. Excuse me, we're going to divide by that. So first we got to do 2.6 multiplied by 50.75, and that equals 131.95. Now we divide by 1.64, and that equals 80.45. So we just round it to the nearest meter. So I'll go back to that our calculator display. The nearest meter would be 80, because this 45 is not going to be big enough to round 80 up any higher. So x is going to equal 80 when rounded to the nearest meter. And there we go. Okay, so this one's called indirect measurement. Show your work, and there's only 10 questions on this one. We made it a bit shorter. Some of them are review questions so that you'll have a little work time at the end. Thank you very much.